So as Kevin said, my name is Sarah Bird. I'm a core developer of Bokeh, a data visualization library, and I'm a software engineer at Continuum Analytics. And today, the title of my talk is Telling Your Data Story with Bokeh. And I've been to a few of the lectures here at BIDS. I think BIDS is an awesome entity within Berkeley, and I'm really happy it exists. And I'm aware that you sort of never know who's going to turn up. It's a fairly diverse crowd. So I've either got something for everybody or nothing that's useful to anybody. So I try to have a bit of a smorgasbord because I know it will be a diverse audience. We'll see how that works out. And some of the themes in here are things that I'm sort of more broadly thinking. They're not finished thoughts is what I'm trying to say. And so I definitely appreciate feedback on Twitter or in person afterwards. And anything that I say that does or doesn't jive with your experiences as real world practitioners in whatever sort of field you're doing, please do let me know. So it's not quite the morning. It was the morning when I wrote the title of the slide. Let's see how sharp you all are feeling after a little bit of food coma at lunch. So we're going to have the next slide up for 10 seconds and raise your hands when you have an answer. Oh, look at that, in the nick of time. Come on then. I don't know what the answer is, but that's some very good pattern recognition skills. You probably should be in a different job. This would make it much easier to count those squares. And so perhaps, obviously, the first part of telling is to, why are we even here in the first place? And data visualization is about visually encoding your message. And I think sometimes when we get into the weeds of things, it's important to just always step back to that high level, why are we even doing this and learning some obscure piece of syntax to make our plot look prettier? It's because we're trying to tell people a message and we're trying to do it visually. So the other sort of high level thing about data visualization is it falls onto a large continuum, I would say, sort of more like a 2D space, where you have very exploratory work at one end and very explanatory work in the middle, and lots of undefined semantic space in between. But on the exploratory side is where you do all your analysis, and for those of you who are data scientists, this is how you spend all of your days. If you're a business analyst looking at sales, projections, or you're trying to figure out how LIGO signals are, whether there's been two black holes bumping into each other or three, this is where you spend your time, and it's where all of the blood, sweat, and tears is. On the other side, you have explanatory, and that's when you get to make something gorgeous that may have less information in it, but it's where everybody's like, oh, show me that pretty graph again, and that's where all the profit is, and where all the for better or worse, that's where that's where it all comes together. So visualizations are a powerful means to tell a story, but did anybody spot the mistake in this slide? I did include 12, and so I hope it goes without saying, but you have to remember to tell the story. And this wonderful person on Twitter gave us a lovely example that they found on the internet of this is not how graphs work. There are so many ways this is wrong. It's unfathomable. But this was actually on television. So I think it's really, really worth saying that it is important to be as accurate as possible and to try and be honest with your data. And I don't think that's as easy to do as it sounds. And I think that's a very interesting conversation to have, especially in the world of science and scientific publishing. I'm forgetting what's next. Okay, right. Yes, next test. What is the purpose of this visualization? You have 5 seconds this time. Oh, yes. No, it's the numbers between 23 and 44, of course. And so the next part of my, the next sort of point, which perhaps is obvious, but I think it's worth emphasizing, is it's important to tell people what you're actually looking for. And so there's this famous quote that is often used in science journalism, which is, don't overestimate, or in journalism in general actually, don't overestimate the public's knowledge, but don't underestimate their intelligence, right? Don't assume that they have all the background that you do, but don't assume they're stupid, right? And this applies to your colleagues as well. Your colleagues are probably working on similar topics to you, but you're like so down deep in the weeds of the specific thing that you're doing that it doesn't mean that just because you're all working on the same thing that they have all the same implicit knowledge that you do. And so I think another way of capturing this is assume an intelligent and impatient reader. And I think we've all been intelligent, impatient readers, consumers of information. And I think that you are your future self's intelligent, impatient reader too. And so when, I don't know if you've ever like said to a friend or your husband, which is the next example, or a colleague, like, how's that analysis coming along? And they're like, here. And this is, I caught my husband with this Excel chart. And this is not the most helpful like answer to your question, like, how's my analysis going? Chart title, no axis labels, random bunch of lines. You know, there's no message in here. You have to dig through the data. You have to spend a lot of time hopefully figuring out the same thing that the person you've asked for information from also understands by this. And let's be honest, this is actually a pretty nice looking Excel spreadsheet. We've all seen much worse examples than this. So at the very least, we're talking about, even if we're talking about fancy infographics and using all these tools like Bokeh, we're still talking about like basic spreadsheet etiquette. So like label your axes, give it a chart title, write an explanation, and like break out the thing that you're trying to say into some kind of standalone thing. So telling your story, you're visually encoding your data, your message, you want to assume you have an intelligent and impatient reader, and you want to be as accurate as possible. Mystery slide. Right, sorry, okay, next point. Okay, so you're working on, I haven't figured out how to do presenter view with this software yet, so sometimes I get lost. So you're doing, you're working on your visualization, and you've started with this, and you're like, okay, well, it's popping out the numbers for me, but maybe if I order them, I'm going to sort of see what I want to see better. And obviously, this is a completely contrived example, but we're highlighting like the numbers under 10 or something. And then this hopefully won't happen to you, but it's happened to me many times where I'm asked to start designing a visualization and start working up how we're going to tell this message before the final data is in. And then the final data comes in, and it looks like this. And all of a sudden, it's like, what's the message here? Is the message the top half of the thing or the bottom half of the thing? And this comes back to the idea of we're visually encoding our message, right? And with the visual encoding, we want the visual to sort of help lead us to the answer. We want it to either show an outlier or show a trend or show, or like it has to be immediately obvious. Now the red, like the starkness of the red in this would like maybe indicate that that's the point. But if both of these had color, like it would be very easy to like not, once the real data had come in, to not have that message really shine through. And this might sound obvious, but I can't tell you how many times this has happened to me. So it could be something as simple as you are designing with your real data, but your real data is a billion points, and so you're just working with a sample of it because you can do that on your laptop and whatever. And then when you go to put the real data on it, you just get crazy overplotting and you really can't see the message anymore. You could have the opposite. You could have underplotting. Variation is something that I find particularly, I've stumbled across a number of times. So I was working with a designer on one side and the client who had the data on another side, and the designer had done this awesome sort of mock-up of what it was going to be, and there was a whole bunch of spark lines, and spark lines are just lines without trends, and in the design they looked awesome because they were all wiggly and it was all like, ooh, look, isn't this engaging? And then the data came through and it was just flat. And then we just had this weird page with a bunch of flat lines on it because we hadn't been working with the real data. And I mean, I guess with a little bit of thought it would have been obvious, but like there's so many things going on. I don't think I'm the only one that's ever made that mistake is what I'm trying to say. On the flip side, I just worked on a project where I worked very hard on this chart that had quite a lot of variation in it, in the actual signal. And so I worked hard on a chart that would sort of clearly display the message, even though there was a lot of variation across a number of plots. And then in the final example, they like tweaked how they did the analysis and smoothed out that variation. And so then like all of that was wasted effort. So maybe I'm spending a lot of time on this because I've wasted a lot of my own time on it and it's personal therapy. But if it happens to you, don't say you weren't warned. So use the real data. And hopefully that's not so much of a problem for most of you. So where are we? Use your data, be accurate, visually encode your message. And now, what is your message, right? We are creating a visualization. Are we creating a story? Are we showing people things? Are we telling people things? And there is just, petabytes of the internet, well, probably not petabytes, terabytes of the internet dedicated to this topic. And in writing, a lot of people say, show, don't tell. You have to don't say the person was scared, say that they were like cowering in the corner and like emoting this and that. And that's fine, but we're not here to write the next great American novel. And I think in data visualizations, you have to both show and tell. Telling is that kind of, this is what you're meant to be taken away from this. That one statement that we talked about earlier that like helps like focus the reader in on why are they here in the first place. But showing the reader, this is why we do visualization in the first place. You're encoding your data into a visualization so that you can compel them with your evidence. You can take them on your journey, and they will sort of like have that knowledge for themselves. And that's where I think that showing part is where visualization really becomes a very, very powerful tool. So your message could be something as simple as sales are up in the Southeast, or as complex as some new scientific finding about how your brain works. It's science. It's definitely science. So it could, but in either case, whether it's this complicated or something as simple as a sales report, it's the same process. And you have to think about why are you doing this in the first place and who you're doing it for, along with the what. Is this for colleagues? Is this for informing and influencing people? Is it internally focused? Is it publicly focused? And so that who, what, why is kind of a constant iteration that once you're holding all of those three things in your head at the same time, hopefully you'll start to focus in on the message. And so once you're sort of moving towards understanding like, why are you doing this in the first place? Who am I talking to? And you're really trying to get to the what, I think it's very important to start thinking about the level of detail. And level of detail and clarity are kind of distinct things. I think a lot of people think that the higher level it is, the like more simplified it should be. And this comes back to don't underestimate people's intelligence, right? Give people a full message. Your job, if it's a complex message, but you're trying to express it succinctly, your job is just to come up with a way of doing that. It's not to dumb down the message. It's to present your message with accuracy and nuance. And so when the computer says, my N is 157 with a mean of 50 and so on and so forth, and your visualization that you have working on your computer says, yep, that's a dinosaur, your next job is, this is the fabulous Anscomosaurus, with credit to Alberto Cairo for making this. This is definitely a data visualization nerd problem. So I've got my data, and now I'm thinking about my message. And when I'm thinking about what I'm going to present to people, am I giving them this kind of like cartoonified version of a T-Rex? He's like pointing to the left and growling. Am I giving like the more sort of nuanced version of a T-Rex, still pointing to the left and growling, but there's a little bit more detail in there? Or am I like all the way in deep with the shading and the texture and whatever, still pointing to the left and growling? And the challenge, I think, with a lot of data visualization is, one, being able to have the clarity that is this first message, right? That is pointing to the left and growling is what we care about here, people. But then if you want people to have that nuance and detail, to like bring them along the journey with you, and to bring that in carefully, because otherwise you could get lost in a whole bunch of different beauty in a picture like that. And so at this point, I don't have like, I stop having like things that are standard to everything that I do. It starts to depend on what you're trying to do. Are you trying to build a story where you explain the whole analysis that you did and you take people along like a very, very complete journey? Or are you trying to do just one, specific, just trying to give people one specific take-home message and let them have at it? So we've just done a lot of, how much have we done? 15 minutes of telling your data story. And so now we're going to go into the with Bokeh part before looping it all back together. So Bokeh is a data visualization library. Has anybody heard of Bokeh before? Wow, okay, I wasn't expecting that. Has anybody used Bokeh before? Okay, awesome. Has anybody successfully used Bokeh before? Oh, there we go. And I saw one other I came to a presentation here at BIDS, and somebody was talking about using Bokeh to do, it was some kind of earthquake thing, and all of the problems she'd had with Bokeh, and like she didn't know who I was and she didn't know I was sitting in the room, but it was really awesome to see somebody who'd like had their struggles, but like used it to get something done, and like at the end of the day decided it was the best thing in spite of the challenges. And I hope we've got a lot better since then. So it's a data visualization library. It's web-based and interactive. We come with the tagline, no JavaScript required, which coming from a web development background is why I fell in love with it in the first place. It can handle large data sets. It can handle streaming data sets. Before I go too far, I always forget to like just show people some stuff, which I think helps to sort of set the stage. So I'm going to show a few examples of a Bokeh app running, and we're going to get into this. So this is just a simple Crossfilter example. This was all built, as I said, with no JavaScript required. Oh, that's kind of boring. Let's do that again. Okay, so we have horsepower on the y-axis, miles per gallon on the left. We can start coloring the things, we can resize them, and so on. Bokeh is a client-side, JavaScript library, so we have all this interactivity built in. But this was all made with Python. We can take a graph like that and start to embed it in a web page and set it in context, and have it do things by itself when my computer's not freaking out. And the Bokeh, I hope by the end of today you'll see a little bit about how Bokeh isn't just a data visualization library. The Bokeh Server is actually a very powerful tool for just building data apps. And so all this is a table. I'm changing the range of salaries that I want to see, and then I have this download button, and it gives me a CSV of the results that I filtered. And this, again, was all built using Bokeh in Python, no web technology required. Ooh. So why Bokeh? Bokeh comes from a data science background, and so one of its original sort of reasons for being was to make interactivity very accessible to data science people who are maybe working in Python or R, and to publish on the web for easy publishing of your results, for portability of your results, for building things like dashboards with streaming and real-time data. From a web developer point of view, which is where I came from and where I decided I liked it, I've always just preferred writing in Python than JavaScript. And then the second thing is I'd been starting to stumble across issues where I wanted to interact with, let's say, 5 to 10,000 points for whatever reason. And in a lot of web technology that uses SVG, you can't do that. You start to blow up your browser pretty fast. But Bokeh can handle that. Whichever side you're coming from, I think Bokeh is a fairly intuitive library. Once you get a hold of a few core concepts, I think it's pretty easy to self-guide. The server-side processing and the Bokeh Server, which you'll see by the end of today, is a very, very powerful tool. And it's open source and extensible. And we've been really working on the extensibility lately, and I'll show you a little bit of that towards the end. So very quickly, this is kind of, we're going into the weeds of Bokeh a bit in case that's useful for some people, and hopefully some of you who might be new to Bokeh will be able to get going with it after today. Bokeh is a very large library, and I think it's a little bit hard to get started with sometimes. So I've tried to just, we don't have much time today, so I've tried to just pull out a few things that I think will help you get to grips with it quickly. So Bokeh has three basic sort of levels at which you can interact with it. At the lowest level, you have Bokeh.models, and all of Bokeh is built up from models, and there you piece together an axis and a plot and a circle and a this and a that and a whatever. And you can control everything, but you do all the work yourself. Bokeh.plotting is a mid-level API, and it uses the models. It just uses the models, but it tries to pick a bunch of sensible defaults for you and do a bunch of work for you so that hopefully you have to do less work to get started and have something sort of out of the box. And then we have Bokeh.charts, which is sort of in a weird category of its own, and it's really designed for like data exploration, one-line chart functions, and just kind of processing your data and spitting out a chart, and that very quick kind of rapid data statistical plotting sort of focus. And it doesn't, at the moment, particularly gracefully bleed into the plotting and the models level, whereas models and plotting, you can very easily sort of move between them as you need to. So I used to recommend starting at charts, but I definitely now recommend starting with Bokeh.plotting, and you'll see some of that today. But before we go there, I want to just, data is at the heart of Bokeh, and so we only have one data structure. It's not rocket science, but it is good to just see it. Is that too small? Is that too small? Yeah. Too small, thank you. I was like, I asked that question wrong. Okay, how's that? Okay, so how many people here know Python? Okay, great. Python's awesome for the 3 people that didn't put their hands up, and it's not that hard to learn. So it's definitely an awesome tool to have in your tool belt. Even if you're not a programmer, it can be very useful. Setting up a basic Python dictionary here with some data in it. Bokeh's column data source will accept that. Or if you're familiar with pandas, Bokeh will accept pandas data frames. I totally recommend Brandon Rhodes' PyCon 2015 pandas tutorial. If you're not familiar with pandas yet, this is a really good way of ramping up on pandas. There's also NumPy arrays and other things that Bokeh will handle happily. But to make a column data source, you just pass in your dictionary of data, or you pass in your data frame. And they basically give you the same result. We've just handled the data frame for you, which just makes things a little bit quicker. So that's that. So that's your data. And then the other main thing you have is your shapes. And so Bokeh has lots of shapes. And basically, with all of these, and all of these, and we might have added one more. Oh, no, not yet. I'm thinking about adding one more. So far, I haven't come across anything I couldn't make, right? These are all the constituent components that you would need to make something. So hopefully it'll become clear how to do that, but they're all of the building blocks that you need are there. And then, of course, data comes with built-in magic. And so, fail. Unlike my presentation. This one. Okay, so honestly, this always feels like magic to me, and I think I know it's not magic because now I'm a core developer of Bokeh, but when I came to Bokeh, it really was like magic. So here we're going to take a first little look at writing some simple Bokeh. We make a column data source like we did before, and I'm diving right into it here, but we're using figure to make a figure. We're going to ask for some specific tools. Is this big enough? Bigger? Yeah? Okay. We're going to ask for some specific tools. we're going to, so this will make us one figure. But then what we're going to do is we're going to say, can my second plot please have the range from my first plot? And can my third plot please have that same range on both, share both the X range and the Y range? So we're going to share some ranges. And in addition to that, on each of our plots, we're going to add a circle, a triangle, a square. And we're going to share the data source. This is the source that we made up here. And once we do that, amazing things can happen. So we asked for some tools. We asked for box zoom. We have box zoom. We asked for box select. We have that. There's pan, lasso, tap, and reset. So first of all, we'll just pan around. And what do we notice? That for free, out of the box, by magic, because we shared our X range objects, the X ranges are now shared. And because we only shared our Y range object with the first and third plot, the middle plot isn't responding to the same pan. Similarly, when we do a selection, we've shared our data source across all three plots. So when we share a selection, now when I select one row, when I select on one plot, sorry, it's picking out a row of our column data source, right? Here's our data, and a row is actually, it's a little bit turned upside down, but X is a column, Y0 is a column, Y1 is a column, right? And so each one of these collections of numbers is an index in our plot. And so this plot is plotting this plot is plotting Y0, this plot's plotting Y1, and this plot is plotting Y2. But when I make a selection, then I can start to see, where do these meet across different plots. This is obviously a toy trivial example, but you could imagine if you were doing like high-dimensional clustering, and you had a grid plot of 30 plots, and you wanted to select a cluster that you'd got between two variables over here, and you wanted to see how that cluster was appearing in your other plots. To spin that up, to write the code to do that with all of that interactivity, is just as simple as making those plots and saying I want my X and Y to be whatever variables I want in my tabular data. So you get all of this interactivity built in, and this is where I think it starts to become a really powerful tool for exploratory analysis. So there's lots of tools that'll happily make you quick charts, your box plots, your histograms, and all that kind of stuff, and they're amazing. But then with Bokeh, you can go this one step further and just get this interactivity for free. Just to show off one other feature, this is the same code, but now I've added some tooltips. And what I've asked for the tooltips to do here is this little @ sign before each is saying, please give me that variable from my data source. And so there's Y0 and Y1. So if I plot it and we start to see it, so here I'm seeing that I'm only plotting X and Y0, but I can happily see the data for Y1, Y2, whatever other data I have in my column data source I can be displaying here. There's a very nice example in the user guide where it pulls up a bunch of snakes and really random stuff. And these can be styled, and so out of the box you get something very simple like this, but you can write your own HTML and start to customize it to your own needs. So there's some of the magic. How are we doing? So it's not actually magic, unfortunately. I know, but I think it's worth. I always think it's worth taking just a couple of moments to explain how it works, because then when you get confused, hopefully you'll have a mental model of what's happening. When you write Bokeh in Python, like we just saw here, we're just writing Python code. As soon as you hit show or save or any kind of output method, all of that Python and all of those objects that you created get bundled into JSON and sent to the browser. And then we have a large Bokeh JavaScript library called Bokeh.js that consumes that JSON and turns it into the plots that you see. And so, ironically, I discovered Bokeh and fell in love with it because I didn't want to write JavaScript anymore. And then I became a core developer, and now I spend all of my days writing JavaScript, so nobody else has to, which I'm not sure how I really feel about that, but it is what it is. Yeah, so that's the sort of core of how it works. So let's go into something. I've covered a little bit of, okay, I'm very sorry. I'm going to nip out of order. How out of order am I going to go? Okay, not too out of order. So I just showed you a little bit of using the bokeh.figure. I still have never figured out how to quite talk about Bokeh Charts, which is why it's out of order yet again. I feel like I do this every talk. So Bokeh.charts is high-speed one-liners that process your data and spit out a chart. And so we can have a quick look at that, and then I'll talk about why I always struggle to talk about the charts. So we're working in the notebook. We use our Bokeh Zone output notebook method. And we're going to import some data. Bokeh comes with some sample data. And then we're going to start importing the charts. So Bokeh comes with a whole bunch of charts just kind of built in, ready to go. And all of these charts consume pandas data frames. Bokeh, the rest of Bokeh doesn't have a dependency on pandas, but Bokeh Charts does. So we can start with a simple scatter plot. We've just passed it in this data frame with a date on the left and glucose and something else on the on the index and the values. And so it's tried to do the best thing it knows how to do, which is not that helpful yet, except what it did do is plot us glucose against ISIG. That might not be what we want, so we're going to look at that a little bit more. The next thing, I think this is a really handy feature of Bokeh Charts, and I kind of wish it was available in the rest of Bokeh, but it's not at the moment. You can set up a bunch of like global defaults, and that'll just sort of default style. Oh, it kind of is available in the rest of Bokeh. Sorry. Things continue to change fast in Bokeh land. I'll talk about that more later. Let's have a look at a time series plot. Okay, this is better. So we had time series data, so time series makes a lot more sense than this. The charts just knew that we had a time series index, so when we plugged it in, it did the right thing, and it gave us a sensible legend. So that's starting to look, yeah. So it's starting to look better. Now, we can also do a horizon plot, if any of you are familiar with them. Not sure what the point of that was. So, scatter, okay, I'm going to run through this very fast because I don't have as much time, but I want to just make a point here. So here's scatter, here's a box plot. Again, we've just thrown in the data set and said how we want to aggregate things, and it's just tried to like do the right thing for us. We made a massive donut plot. Wow. And then I tried to make a better donut plot, but that is not a good donut plot. And the reason I knew this was coming, this is not a mistake, is because exploratory data analysis is like this, right? You're just messing around with your data, and you're seeing what works, and you're saying, well, that doesn't work. Okay, I definitely want a bar chart for that. I'm probably going to want to, like, you know, order it by count in this case. Or I might want to, I don't know what I've even done in this one, put some different things in. Anyway, I want to do a stacked area plot. I want to, do I have any more? I want to do a dot plot. I might want to do a lot of things, and the Bokeh Charts is there to just kind of let you throw in a data frame and hopefully do the right thing. It has a bunch of aggregations like mean and sum and all that kind of stuff. It's very pandas centric, and hopefully it'll feel familiar to you if you work with pandas. However, don't push it too far, I think is the best way of saying it. Where were we? Right, don't push it too far. It's designed to help you quickly explore your data. It's not designed to do all of the richness that Bokeh can do. And I think that, I did it again. I think that this is something that we haven't done a good job of explaining, and I would definitely welcome feedback on that. So now I'm going to switch gear completely and come back to storytelling and come back to, I sort of know where I'm going, and I'm going to show you a little bit about building up a plot in Bokeh and hopefully exposing some of the features that we have. So we have a very simple data set. It's the Gapminder data set that you may have seen before. We're just going to import show and figure, and we're just going to start with a super simple plot where we just, we don't pass any arguments to figure. This is hopefully slightly cleaner code than you saw before. We're going to say X is this column, Y is this column. We could pass in, you can pass in a column data source and work with your column data source, or you can just throw in lists of data. You can start to throw in a few things and make things a bit easier. So I've changed it to be a log axis type. I've started to specify the ranges that I want so that I can, you know, for whatever reason I might want to do that. I can very simply add some color in. And, you know, we're starting to we're now at the point where we're tweaking styling. We are not tweaking the message. You should know the message, and this comes back to where we were before. If you don't think you know where you're going, coming back to the sort of wasting your time idea of, you know, when you're not working with the real data, you can also waste your time when you're not working with the right message. And I was working on a project before where we had, it was a huge modeling project, like many grad students, a lot of work, and they'd done sort of the initial analysis, right? But there was a deadline coming up, and we wanted to start building the visualizations, and they were still, so we started to work sort of simultaneously with them, still doing analysis and me building visualizations. And as we were getting a little close to the deadline, we got to put it all together with the final results of the analysis and my visualizations, and we saw for the first time the data on a map, which is not something they were doing as part of their standard analysis. And all of a sudden they realized that the message they thought they had about how these different properties sort of broke out geographically wasn't actually what they thought was happening. And so you definitely want to make sure, both in terms of when you're starting to really get deep into this customization, make sure your message is right and make sure you're working with your real data. So, tangent over. Come back. Hang on. Okay. We made it bigger. Okay, so one other thing that is very new to Bokeh and is kind of an obvious need for a data visualization tool is the ability to map between your data and your visual properties. So this example here, again, you're not going to grok all the code straight away, but I just want you to know that they're there. So we were plotting X and Y, and we could see the correlation here between income on one axis and life expectancy on the other, but now we can start to map some other visual properties. So we're mapping size to our population, and we're mapping color to a categorical map of the regions that are of the world. And so with all of that in place, we have a plot that looks like this. We've added a nice hover so we can see which countries. Unsurprisingly, you know, China's one of the big blobs, India's another big blob. And now we're going to start doing some interactivity. And I'm going to start in the Jupyter Notebook because Stefan put your hand up. Yeah, is Fernando here too? You guys, oh, okay. Well, there is free Jupyter Notebook support at all times in the BID's office. So I thought I'd start with some Jupyter Notebook before we see it natively in Bokeh. But Jupyter and the IPython world have these widgets that work in the notebook. And they give you a slider, which is being very jumpy right now, I think, because I've got so many tabs open. Give you a slider that lets you interact with your data. And I want to show you how simple that code is. So the slider is giving us a new year. And so with that new year, we can make a new set of data, right? That's just some pandas code. And it'll look very familiar to it looks like the code we made before when we just made a static plot. Then all we have to do is say, the data source that's powering the plot, give it the new data, change the title to be the year, and then in the notebook, we use this push notebook method, which is what causes it to all sync up. And it just magically works, which is kind of awesome. So but in Bokeh land, so that's how you might do interactivity in the notebook, and it's how you might want to do it if you're if you're just, especially if you're just doing exploratory analysis and you just want to stay in the notebook. But Bokeh comes with this thing, Bokeh Server. And it's really, it's awesome, is the words that I'm struggling to say. I'm going to start with a very simple example, which looks like nothing, but really sort of highlights the magic. We've got 4 sliders. We've got a text box here, which changes the title. But what's actually happening here is that every time I change this, it's calling back to a server, and this is running on the actual live internet. This isn't running locally. It's calling back to a server, and it's saying, please update the data that's powering this plot. And so I want to take a quick look at the code that powers this so you see how easy it is. And we will make this much bigger. So we make a plot. This hopefully looks familiar to you now. We add a line, and then we set up our widgets. We have a text input and 4 sliders. You can look up how to configure these yourselves, but hopefully this is fairly easy to read. And then this is where the magic happens. We have 2 callbacks for updating the title and for updating the data. And then for each widget, we say, when the value changes, please run this callback. And again, all we have to do is just like I showed you in the notebook. You just set the source's data to the new data. And that's all you have to do. You don't have to understand WebSockets. You don't have to understand all the technology that's hooking the front end to the back end and all of that magic. And that happens, if you write this code, you will get out that interactivity. And you'll get out that interactivity. What am I trying to say? I forgot what I was trying to say, sorry. Right, and the point of this is that you can run, this is trivial, running a slider is not going to make you sing. But if you happen to have a clustering algorithm that you wanted to power based on a user's dropdown, or you wanted to go and get more data from the cloud, or you wanted to run a streaming data would work without the user interaction, right? You can have a method here that says, every 50 milliseconds, please go and check for there's new data. And if there is new data, add it to the plot. Add it to the plot, stream my new data. And that's all you need to do to set up a streaming data plot. And this, it's kind of amazing how, like, if I think back 2 years ago, I would have easily felt comfortable saying it'll take me 2 weeks and $10,000 to build this for you, right? Like it's a pain in the butt, like setting up servers and making a callback between the front and the back end and whatever. And Bokeh just does that for you. And that's where I think this real power of the Bokeh Server as a more general sort of application tool comes in. We did Bokeh Charts. And so the last piece I want to show you is Dask and the microscopian demo. So this is an example, a real-world example of somebody using the Bokeh Server. And I'm just going to talk over him for now. Dask is another library that it's an open source library that Continuum is the sponsor of, and it makes distributed computing very easy. It gives you a pandas type interface, but then you can start to run your aggregates, your group bys, whatever your pandas queries might be, but over a cluster of data. And that cluster might be an actual cluster in the cloud, or it might be as simple as running out of core on your machine. So if you have data that's like a terabyte, so it's big enough to fit on a hard drive, but it's not big enough to fit in RAM, you can use Dask to crunch all that locally without having to get into really complicated solutions. These are pandas. It's going to feel like a pandas API. But what I wanted to show you was they've built this web sort of dashboard all on Bokeh that's interrogating all of the processes as they happen. So when you do, this is an example of them doing some scikit-learn calculations. And so in order to distribute them, they've broken up the task of a group and an aggregate and whatever into a whole bunch of small functions. And they know, like, send a bunch of work here and send a bunch of work there. And so what we see here is all of the different workers that they've sent work to, and what the different colors are, all the different types of functions. So this is probably a bunch of like sums happening first, and then some group bys, and then you can start to see this. And so this is an example of how they've built Bokeh into a real application, streaming real time, to enable them to really debug and understand what's going on in a very complicated distributed computing type system. So that's a fairly complicated example. All of the code for that is open source. One of the things that Matt Rocklin likes to point out is this massive red here is where they deliberately highlighted, I think it's I/O, and so you can very easily see when some of your, they've used a visualization, this is the whole point of this story, of this talk, they've used a visualization to like scream loudly at them that they have I/O blocking their computation, right? And this is, you know, one of the things that this visualization has brought to them. It's brought them the ability to optimize and debug their own functions that they're writing. On a much simpler example, this is a prototype that I've been working with a friend of Stefan's on, and I've used some core bokeh. This is it's to do with biology. I'll just start waffling. So anyway, they're doing this is a PCA, like nearest neighbors clustering. And they want to see the image that represents each one of these points along with the nearest neighbors beneath. So I've used some built-in bokeh, but then I've also used the fact that you can now build bokeh extensions. This is a custom image that just is an HTML image that is displaying on bokeh callbacks. And so not only do you have all of the built-in batteries that bokeh comes with, but you can start to build your own if you don't like what bokeh has to offer, or you need to customize it in some particular way. And a really extreme example of that is this 3D plot. Bokeh doesn't do 3D plotting, and I sometimes regret showing this example because people are always like, when are you going to have 3D plotting? We're not going to have 3D plotting anytime soon. But if you have what we've done is we've hooked in a 3D rendering engine, the Viz.js library, into Bokeh. So the data is coming from Bokeh. We've hooked up that back end to front end using Bokeh, and so you don't have to worry about any of the web tech. But the bit that's doing the rendering is this other third-party library. And hopefully this just gives you a flavor of what Bokeh is capable of. I will just point you to one last thing. We just wrote a blog post called Guide to Resources on our blog. There's a lot of things to know about Bokeh, and we've tried to explain how you can sort of start to get to grips with it. In particular, how to get hold of the example applications. So we have a gallery on our website, but it has maybe 20, 30 examples. But the examples folder themselves has maybe 100, 150 examples in it. So it's really worth digging into that. And I still use that. Bokeh is big enough that not even the core developers can remember how it works. And so I still, on a regular, daily basis, go and have a look at an example to remember, there's this one. I know there's this one specific feature, but I can't quite remember how it works. So I totally recommend checking out this blog post if you're interested in really getting to grips with Bokeh. There's a bunch of YouTube videos. A number of them have me in them. I think it's worth remembering that Bokeh's been moving really fast over the last 2 years, and so anything that's more than 6 months old, you might want to be a bit wary about. But the good news is that we're slowing down. We're coming on a 1.0 release at the end of this year. And at that point, when we hit 1.0, we're guaranteeing the API stability. We're going to stop breaking things. And so this incredible arc that we've been on is going to really start plateauing. So that's kind of an exciting milestone that's coming up. For the last 10 minutes, I wanted to go back to data storytelling and hopefully calm down. I always get excited when there's a lot of code, and I'll just take a deep breath. So let's look at somebody else's awesome work, like this amazing data visualization from 538, which has all of these different features. All of this, I'm pretty sure you could do with Bokeh. And it's all about sumo wrestlers if you're into sumo wrestling. Or this, so I'm a new US citizen and the election coming up is very exciting. And so it's one way of putting it. And it's fascinating. Anyway, this is a really intense visualization from the New York Times where you can do some filters by ethnicity, by gender, and so on. And there's a lot going on here, and you can really start to dig in, how do white women aged 30 to 44 with high school degrees in Arizona, how do they vote and what was their turnout in the 2012 election? You could explore this to a great degree. And similarly, we have the Gapminder example that we just very quickly built up in time, which is talking about how over the last sort of 60, 70 years, countries have moved from being very distinctly separate to being more of a blob of countries. And I'm going to take a minute and say that whilst I'm a big fan of this graphic, because I made it myself, and people like it, it sort of pales in comparison to this, which we're not going to have time to watch all of.
First, an axis for health, life expectancy, from 25 years to 75 years. And down here, an axis for wealth, income per person, $400, $4,000, and $40,000. So down here is poor and sick, and up here is rich and healthy. Now, I'm going to show you the world 200 years ago, in 1810. Here come all the countries. Europe brown, Asia red, Middle East green, Africa south of Sahara blue, and the Americas yellow. And the size of the country bubble showed the size of the population. And in 1810, it was pretty crowded down there, wasn't it? All countries were sick and poor. Life expectancy were below 40 in all countries. And only UK and the Netherlands were slightly better off, but not much. And now, why start the world? The Industrial Revolution makes countries in Europe and elsewhere move away from the rest. But the colonized countries in Asia and Africa, they are stuck down there. And eventually, the Western countries get healthier and healthier. And now we slow down to show the impact of the First World War and the Spanish flu epidemic. What a catastrophe! And now I speed up through the 1920s and the 1930s. And in spite of the Great Depression, Western countries forge on towards greater wealth and health. Japan and some others try to follow, but most countries stay down here. Now, after the tragedies of the Second World War, we stop a bit to look at the world in 1948. 1948 was a great year. The war was over, Sweden topped the medal table at the Winter Olympics, and I was born. But the differences between the countries of the world was wider than ever. United States was in the front, Japan was catching up. Brazil was way behind, Iran was getting a little richer from oil, but still had short lives. And the Asian giants, China, India, Pakistan, Bangladesh and Indonesia, they were still poor and sick down here. But look what is about to happen. Here we go again. In my lifetime, former colonies gained independence, and then finally they started to get healthier.
I'm going to save the no spoilers. You can watch the rest on your own. The thing there's so much that's different about that than this, even though it's essentially the same plot, or the one we were working with before, which had income along the bottom, was the same plot. And what he did there was he took us through, you could only pray that you would, it's just so unlikely that you would ever have a reader look at one of your charts and say, ah, yes, I see this on the bottom, I see this on the top, therefore I understand what each quadrant of this plot means. Okay, you know what I mean? He draws you through it in a way that, and he picks out those little vignettes of China is moving along here and what's happening with this particular story. And he takes that wonderful pause and says, and I was born in 1948, and, you know, and gives you that kind of personalization, like how do you relate to this data? There's so much that he does well in that, that I think is sort of the hallmark of telling a good story. And I want to now do, I cheated a little bit with the two examples I showed you before. New York Times and 538 are both very sophisticated data visualization people, and they did not just throw those at you. They started with articles like this. They start with a giant blob which explains that this is turnout and this is how people voted. And then they say, okay, we're going to break it up by race. Now we're going to break it up by education. And as you move through, you get this sort of incremental reveal on what is actually going on in this data, such that you can then sort of feel empowered to really go in and understand it. And I don't think it's reasonable to, I mean, I introduced the chart to you, right? But like, without, but I'd already seen this myself. So like without something like this to take you through, I don't think it's reasonable for people to sort of elicit meaning from your data visualizations. And similarly for the sumo wrestler ones, it actually starts in this kind of slideshow way where it starts off sort of setting it in historical contents. We've got the context, sorry. We've got the Declaration of Independence over here. We've got the Super Bowl. And it moves you through. Here's a little vignette of a particular sumo wrestler, the Thunderbolt, a modern-day hero over here, and so on. And so you get led through. You get to see that there's other kinds of axes, and then you're sort of thrown into the exploration phase yourself. And so if you're building a big like capstone visualization like this, or even like the Gapminder, which isn't wildly complex, but you have to remember that your reader might appreciate your aesthetic and might get excited and want to share it, but if you want them to take home the understanding that you have to lead them through that journey. And so that's what I wanted to leave you with. I think that when you're telling your data story, remember you are visually encoding a message. You need to know what that message is. You have an impatient reader. You have to highlight illustrative examples. You have to be truthful. Remember to use your data to do your design work, otherwise you will weep. And remember to craft that narrative. And do it with Bokeh, because Bokeh is awesome. And it does have all of the tools for you to make very, very complex, beautiful graphics, as well as all of that early exploratory work. And so it provides you a way to transition from the exploratory phase over here through to the explanatory phase. And with that, I will take questions.